The universe just blinked. The James Webb Space Telescope, JWST, spotted the earliest confirmation black hole ever, revealing how quickly cosmic structures sprang to life and forcing a rethink of black hole origins. So the James Webb Space Telescope confirmed an ultra-early supermassive black hole in galaxy Capers-LRD-Z9, only approximately 500 million years after the Big Bang. So tell us what's going on here, John.
Yeah. So this just blows my mind, right? When we're talking about the JWST. So what they've done is, using the JWST, they've identified a mysterious, let's call it a little red dot called QSO1. And it appears to be a massive black hole. How massive, you ask? 50 million times the mass of our sun, with almost no galaxy around it. So it's like finding a cosmic whale in a goldfish bowl. The proportions are completely backwards from what we expect. So why is this revolutionary? It's because normally we think stars form first, then galaxies, and finally black holes grow inside them. But QSO1 suggests the opposite might be true. It suggests that black holes formed first and galaxies grew around them, which is weird to me. And this object that they observed appears to be from when the universe was only 700 million years old, in an almost pristine environment of just hydrogen and helium. It's crazy that it says that it's only 700 million years old. The implications of this is that if this is confirmed, this discovery could actually validate Stephen Hawking's decade-old theory about primordial black holes, which potentially solve the mystery of dark matter and explain how supermassive black holes got so big so fast in the early universe. It's like, when we're doing something like this, it's literally looking back in time to see how the universe's most fundamental structures formed. And it's crazy what we're able to achieve and observe with the JWST. Hey, Craig, what are your thoughts?
Seem to almost every week, if not every day, getting new things that change our understanding of the universe. Planet-eating suns and how black holes eject mass rather than suck it all in. And there's a few other things that go on, and, white holes inside of a black hole, and, they glow with radiation energy, and, all these things. And we're talking about a new discovery in the last several episodes around how that changed how they thought early galaxies were formed and why certain galaxies stopped forming right away. So now we're taking a look at this, and, we're talking about the black holes like started seconds after the Big Bang and then evolved coexistent with galaxies. So, it changes everything when we think about all this stuff. But so, what are black holes? Why did they exist right from the beginning? What does evolving mean? Like, it's a supermassive, but when it starts as a red dot and then goes to, we see it as a red dot because it's so far away and whatnot. But, it starts small, but all of a sudden it grows to this supermassive black hole, 50 million times our sun. Like, watching that grow in our galaxies, it's just like, what does it mean? We're now talking. Scientists think that there are time tunnels that could be millions of years into the past or in the future and stuff like that. I'm really curious as to what they really are and how they evolved in time along with the galaxies.
Oh, for sure. Cool. Like, the cool thing about this, which kind of blows my mind, is that the discovery of this QSO1, it was only possible through a cosmic alignment. So, although all you, I can't remember the name of it, but anyways, so there is a massive galaxy cluster lies directly between Earth and QSO1, which created what astronomers call a gravitational lens. So Einstein's general relativity predicts that massive objects bend space-time, and this bending magnifies light from objects behind them. So in this case, this natural telescope effect allowed researchers to study an object that would otherwise be too faint and distant to analyze in detail. How crazy is that?
It's crazy. And the little red dot galaxy's extreme luminosity may arise from the active nuclei powered by the voracious acertation. The rapid growth suggests coevolution of black holes and host galaxies shaping each other from inception onward. So the study strengthens the case for a systematic surveys targeting compact infrared bright sources at the highest redshifts for confirmation. So we're looking for these red dots to discover more and find out more information.
Yeah. And so this represents one of the most compelling dark matter candidates because they naturally possess all the required properties. They're collisionless, stable if massive enough. They have non-relativistic velocities, and they form very early in cosmic history. So unlike hypothetical dark matter particles, these PBHs are composed of ordinary matter and require no exotic physics beyond general relativity, which kind of blows my mind because I'm still trying to wrap my head around dark matter and how we can't detect it, but yet this there's a lot to unpack here that that they're talking about that just, and we covered dark matter before, right? So this is throwing more into that unknown for me, if that makes sense.
Yeah, and this is just a theory. We need to go in. Observational limits currently bound primordial searches, motivating next generation instrumentation and gravitational wave complementary probes and surveys to follow up with the James Webb Telescope. So, and it suggests that coevolution indicates that black holes may drive, not solely follow, the hierarchical galaxy assembly. So, like, there's a lot of things that this kind of reframes about the Big Bang and the evolution of the universe and how everything works together. So, I'm really interested in watching how this goes and, how far back you can go practically with their instruments, and they get better and better. I wouldn't be surprised within a few months they've got more information. They start running this stuff more through quantum computers and they find more signals in the noise, more stuff from space. We talked about that signal from space, but I think it was just at the intro, that we didn't cover an article on that you had mentioned a while ago.
Yeah.
Anyway, we'd love to know what your thoughts are on the universe's first seconds and these primordial black holes and how role they played in building the universe, from little red dots to 40 million solar mass giants. The James Webb Space Telescope is rewriting our cosmic origin story. Curious, stay skeptical, and watch the next instruments push even further back that curtain of the beginning of the universe time. Let us know what you think and leave your comments below. What do you got going on, John?
Oh, just working away, helping companies secure government funding. Maybe heading to a couple events. Not sure what's coming up. So this will probably come out after Elevate.
Yeah.
So Elevate probably would have been a great time. But yeah, how about you, Craig? What do you have?
So assuming this is November, we've got a Flowgrammer event and a Toronto Startup Investor Drinks. If you're in the GTA area and want to learn or be part of a Flowgrammer, N8N, or Vibe Coding meetup group, join us. Go to flowgrammer.ca and check out the upcoming events and join us. If you want to find out more about how to take your startup to the next level, head over to torontostarts.com. Our events there, Startup Investor Drinks. So we do monthly. It's open bar, open pitch. It's an intimate event, and the conversations are next level. So check all that out there, and we'll see you in the future. Anything else, John?
No, that's it.
So thanks, everyone, for listening. Don't forget to like and subscribe and leave a comment. We really appreciate it. Have a great one.